Hello, dear children. Welcome to the class. Today is the second session of this chapter, Measure of Correlation. In the first session, we have learned the meaning of measure of correlation, and we have also talked about one of the measure of correlation, that is scatter diagram. Today, we'll be discussing the merits of the scatter diagram and how to interpret the scatter diagram. And then we'll be proceeding towards the next measure of correlation, that is Karl Pearson coefficient of correlation. We'll be learning how to calculate Karl Pearson coefficient of correlation. So let's begin with this topic, how to interpret a scatter diagram. Now, dense or scattered points. If the points, that is dots, are close to each other, a high degree of correlation may be expected between the two variables. However, if the points are widely scattered, a poor correlation may be expected between them. अगर बेटा densely plotted होते हैं तो यानी कि there is high degree of correlation between the variables. लेकिन अगर densely plotted नहीं है, scattered है, widely scattered है, that means that there is a poor correlation between the variables. Second is trend or no trend. If the points on a scatter diagram shows any trend, either upward or downward, then variables are said to be correlated. And if no trend is revealed, the variables are uncorrelated. Fine. If there is an upward trend, that means the variables are positively correlated. If there is a downward trend, that means the variables are negatively correlated. And if there is no trend revealed, that means that the variables are not correlated. Upward or downward trend, there is an upward trend rising from lower left hand corner and going upward to the upper right hand corner. The correlation is positive. It means values of two variables move in same direction. On the other hand, if points depict a downward trend from upper left hand corner to lower right hand corner, the correlation is negative. It means values of the two variables move in the opposite directions. Positive correlation, if the points on the scatter diagram lie on a straight line with positive slope, then correlation is perfect and positive. On the other hand, if all the points lie on a straight line with a negative slope, then there is a perfect negative correlation. यानी कि perfect correlation कब exist करता है? जब जो points हैं scatter diagram में, they lie on a straight line. Positive slope होगा तो there is a perfect positive correlation, और अगर negative slope होगा तो there is a and the points are lying on a straight line, then there is a perfect negative correlation. Now see, this is an example. Make a scatter diagram for the following data and state the type of correlation between x and y. Now x variables are plotted on x-axis and y variables are plotted on y-axis. 10, 20, 30, 40, 50 on x-axis. Your 1 unit is equal to 10 units, or your 1 box or 1 centimeter is equal to 10 units. And on y-axis, the units are 70, 140, 210, the gap of 70. So 1 centimeter on y-axis is equal to 70 units. So you can see when we plot 10, 70, 20, 140, 30, 210, 40, 280, and 50, 350, and we join these points, we are going to get perfect positive correlation between the values of series X and series Y. Now draw a scatter diagram to represent the following type values of X and Y variables and comment on the type and degree of correlation. Now when we plot this x and y variable, x variables on the x-axis and y variable on the y-axis. On x-axis, 1 centimeter is equal to 5 unit. Similarly, on y-axis also 1 centimeter is equal to 5 units. When we plot this combination, x 15, y 7, we are going to get this point, first point. Then x 18, y 10, the second point. Then x 30, y 17, third point. X 27, y 16, fourth point. And x 25, y 12, the last point. You can see that there is a upward trend of the dots from lower left hand corner to upper right hand corner. It means there is a positive correlation between values of x and y, but since these dots are not in a straight line, so that means the correlation is existing but not a perfect positive correlation. It's just a positive correlation between the values of x and y. So the merits of scatter diagram, first is simplicity. It is simple and non-mathematical method of studying correlation between two variables. No calculations are involved. Second merit is it is easily understandable. It can be easily understood and interpret. It enables us to know the presence or absence of correlation at a single glance of a diagram. आप बिल्कुल देखते ही पता लगा लेते हो कि ये positively correlated है या negatively correlated है variables. And the third merit is it is not affected by the extreme values. It is not influenced by the size of extreme values, whereas most of the mathematical methods lack this quality. Fine. And first step, it is a first step in investigating the relationship between the two variables. Exactly कितना correlation exist करता है वो तो हम जब दूसरे मेथड यूज करते हैं लाइक कार्ल पियर्सन कोफिशिएंट ऑफ कोरिलेशन या रैंक्स पियर्समैन कोफिशिएंट ऑफ कोरिलेशन से पता लगता है. बट this method of preparing scatter diagram, it's a first step in investigating the relationship between two variables. The demerits of scatter diagram, first is it's a non-mathematical method. So this method does not indicate the exact numerical value of correlation, which is possible by other mathematical methods of correlation. It's just a rough measure. It gives only a broad and rough idea of the degree and nature of correlation between two variables. Thus, it is only a qualitative expression rather than a quantitative expression. Fine. Exact measure कितना है, exact degree कितनी है, numerical value क्या attach हो रही है correlation के साथ, this we cannot calculate or predict using scatter diagram. This method is unsuitable for large observations. It is not possible to draw a scatter diagram on a graph paper in case of more than two variables. Scatter diagram method shows the existence and direction of correlation. However, it does not quantify the extent of correlation. That is, it does not indicate the exact numerical value of the correlation. I hope that the merits and limitations of scatter diagram are clear to everyone. The next measure of correlation is Karl Pearson coefficient of correlation. There are four methods of finding Karl Pearson coefficient of correlation: actual mean method, direct method, shortcut method, or the other name for shortcut method is assume mean method or indirect method, and finally the step deviation method. Now let's first understand the algorithm of calculating Karl Pearson coefficient of correlation by actual mean method. Now, as the name indicate, actual mean, there are going to be two variables, x variable and y variable. Two series will be there. So first step, calculate the mean of the two series, x and y, and let it be represented by mean of x and mean of y. Second step, take the deviations of x series from mean, that is mean of x, and denote it by small x. Third step, square the deviations and obtain the total. That is, we are going to get the summation of small x square. Fourth step is take the deviations of y series from mean of y and denote the deviations by small y. Fifth step, square these deviations and obtain the total, that is summation of y square, small y square. Sixth step, multiply the respective deviations of x and y series and obtain their total, that is summation xy. Now substitute the values of summation xy, summation x square, summation y square in the formula, that is summation x square upon under root of x square plus y square, and this formula is going to give us the value of Karl Pearson coefficient of correlation. I hope that this algorithm is clear to everyone. Let's solve. Let's take one practical problem. Calculate the coefficient of correlation for the following data. Karl Pearson coefficient of correlation by the actual mean method, and the data is there in front of you. So this is our X series 12, 15, 18, 21, 24, 27, 30. Summation X is 147. All of us know that mean is equal to summation X over N. There are 7 observations. So 147 divided by 7. So the mean of the X series is 21. Similarly, Y series 6, 8, 10, 12, 14, 16, 18. Summation y is 84. And when 84 is divided by 7, as there are 7 observations, we are going to get mean of y as 12. Mean of y as 12. Now the next step is that we are going to calculate the deviations from the mean. So 12 minus 21 is going to give us minus 9. See, mean of x is equal to 21. Mean of y is equal to 12. Now 12 minus 21 is equal to minus 9. 15 minus 21 is equal to minus 6. 18 minus 21 is equal to minus 3. 21 minus 21 is equal to 0. 24 minus 21 is equal to 3. 27 minus 21 is equal to 6. And 30 minus 21 is equal to 9. Fine. So we are going to take these are this second column is of small x, that is deviations of x, all the x variables from the mean of x. And then finally in the next third column we are going to take the summation of x square. So 9 square is 81, 6 square is 36, 3 square 9, 0, 3 square 9, 6 square 36 and 9 square 81, and summation x square is 252. Similar steps we are going to follow for y series also. Now from the y series, as the mean of y is 12, so 6 minus 12 is minus 6. 8 minus 12 is minus 4. 10 minus 12 is minus 2. 12 minus 12 is 0. 14 minus 12 is 2. 16 minus 12 is 4. And 18 minus 12 is 6. Now this the fifth column is your small y, that is deviations of all the variables of y. You are calculating the deviations from the mean of y. And then the next column is your y square. So 6 square 36, 4 square 16, 2 square is equal to 4, 0 square 0, 2 square 4, 4 square 16 and 6 square 36, and summation y square is equal to 112. Now the second last step, we are going to calculate small x into small y. That is, we are going to multiply this second column with the fifth column, and we are going to get this seventh column. So when we are calculating seventh column, what we are doing, we are multiplying the second column with the fifth column. Fine. So this is how we are going to calculate this last column. So 9 6 are 54, and minus into minus is plus. 6 into 16, sorry, 6 into 4 is 24. Since both are negative values, so the product is going to be positive. Minus 3 into minus 2 is plus 6. 0 into 0 is 0. 3 2s are 6, 6 4s are 24, and 9 6 are 54, and summation xy is equal to 168. Now we have calculated summation xy as 168, summation x square is 252, and summation y square is equal to 112. Now let's substitute the values in the formula. The formula for calculating coefficient of correlation, which is represented by a small r, is summation xy upon under root of x square into y square. We'll substitute the values. 168 upon under root of 252 into 112, and the product is 28,224. Now if we'll take the square root of 28,224, we are going to get 168. So 168 upon 168, the coefficient of correlation is 1. It's positive 1. That means there is a perfect positive correlation that exists between x and y variable. I hope that the method of calculating coefficient of correlation by actual mean method is clear to everyone. Let's move towards the next method of calculating Karl Pearson coefficient of correlation, that is direct method. The coefficient of correlation can also be obtained without finding out deviations from the actual means, and the steps involved in direct method are, see, हमारे पास बेटा x और y series given होती है. हम क्या करते हैं step 1 में, calculate the sum of series x and denoted by summation x. This is capital X. And step 2, calculate the sum of series y and denoted by summation capital Y. Step 3, square the deviations of X series and obtain the total. That is, we are going to get summation X square. Step 4, square the values of Y series and obtain the total as summation Y square. Step 5, multiply the values of series X and series Y and obtain their total as summation XY. Substitute the values of summation xy, summation y, summation x, summation x square, and summation y square in the following formula. The formula for calculating coefficient of correlation by direct method is, it's given by n. N is the number of observations, paired observation, into summation xy minus summation x into summation y upon under root of n into summation x square minus summation x का whole square into under root of n into summation y square minus summation y का whole square. Now we can see the same question. These are the x variables. Find the first column first column, you can see that the x variables are given as 12, 15, 18, 21, 24, 27, 30. Then the second column is that we are going to take the square of the first column. So second column is nothing but the square of the first column. Like 12 square is 144, 15 square 225. Likewise 30 square 900. And the next step is to calculate the summation x square, which is 3339. Then third column is your y series. It's given to us. Your fourth column is nothing but the square of the third column. We are going to take the square of all the observations given in the third column and represented it as capital Y square. So 6 ka square is 36, 8 ka square 64, 10 square 100, likewise 18 square 324. Then we'll take the summation of Y square, which is 1120, and the last column, that is the fifth column, is this fifth column. This we are going to get by multiplying the first column with the third one. Multiply x series with y series. So first column is multiplied with the third column, and we are going to get the product like 12 6 72, 15 into 8 120, 18 into 10 180, 21 into 12 is 252, 24 into 14 is 336, 27 into 16 is 432, and last 30 into 18, which is equal to 520. And then we are going to take the summation of xy, which is 1932. Now we have summation x as 147, summation x square as 3339, summation y as 84, summation y square as 1120, summation xy as 1932. Fine. So the coefficient of correlation, we are going to put the values in the formula. N into summation xy minus summation x into summation y upon under root of n into summation x square minus summation x ka whole square into under root of n into summation y square minus summation y ka whole square. So when we'll substitute these values, we are going to get the equation like 7 into 1932 minus 147 into 84 upon square root of 7 into 339 minus 147 ka square into square root of or under root of 7 into 1120 minus 84 ka square. And when we'll solve this, we are going to get again 1176 upon 1176. So the coefficient of correlation is 1. So that means the values, again the answer would be same. Whatever method we are going to apply to calculate Karl-Pearson coefficient of correlation, the answer will be same. It is plus 1. So that means there is perfect positive correlation that exists between the variables x and y. I hope that both the methods of calculating Karl-Pearson coefficient of correlation, that is actual mean method and direct method, is clear to everyone. Hope all of you have enjoyed the learning today. Practice as many questions as you can from whatever book you are having. That's all for today from my side. In the next class, we'll be learning the other two methods of calculating Karl-Pearson coefficient of correlation. That's all for today from my side. Thank you very much.